Okay, so this is a question from May-June 2016, variant 7.3, question 2. In the past, the mean annual crop yield from a particular field has been 8.2 tons. During the last 16 years, a new fertilizer has been used on the field. The mean yield for these 16 years is 8.7 tons. Assume that yields are normally distributed with standard deviations 1.2 tons. Carry out a test at the 5% significant level of whether the mean yield has increased. Okay, so this is the questions here. Now, first step, we try to define the random variable and its parameters. So what random variable do we have here? We are looking at the sample mean, right? The mean yield. So since we are talking about sample mean, it is following a normal distribution because the yields are normally distributed. Then the sample mean of the yields is also normally distributed. Okay, where the mean should be given as 8.2, right? It has been 8.2 tons, the mean annual crop yield, 8.2. The standard deviation given to be 1.2, but this place is meant for the variance, so I put a square. And don't forget, this is the sample mean distribution, must divide by sample size, 16, right? For the mean yield of 16 years. Okay, that is the normal distributions, the random variable, and then the parameter, the mean and variance. So second, define the null and alternative hypothesis. So the main point of this is, in the past, the mean, the parameter, right, the mean has been 8.2 tons, the yield. But after the use of the new fertilizer, they want to see whether the mean yield has increased. So the H1 will be greater than 8.2. Okay, so that is what we want to figure out, whether the mean yield has increased. Then the third, determine the critical region. Like I showed you just now, since the significant level given in this test is 5%. And refer to the bell-shaped curve. So since we are looking at this, and this is what we call the one-tier test, because we are trying to see whether the mean is greater than 8.2 or not, right? And since it's looking towards the right-hand side, we also can call it as right-tier test. So this is the probability of the significant level, 0.05, and the z-score value that I found just now, 1.645. Okay, so that is the critical region. I'm going to reject the H now if the z-score value is greater than 1.645. Okay, now I have determined the critical region. So we need to calculate the test statistic. So what is the test statistic here? So I'm going to find out the z-score, which means the standardization is the test statistic here. So how do we carry out the standardization? We take the sample mean minus the population mean divided by the standard deviations. Okay, so in this case, the sample mean is, what is the value of the sample mean? Look at the questions. The mean yield for these 16 years is 8.7 ton. So that is the mean from the 16 years, right? From the sample, the 16 years sample. So 8.7 is the sample mean. So minus the population mean divided by 1.2 over square root of 16 years. Okay, so find out this value. $1.667. So then, what's the next step? Compare the test statistic with the critical region. So since the z-score value found to be 1.667, and does it fall into the rejection region? Refer to C. I will reject the H now if the z-score greater than 1.645. So it is 1.667 is greater than 1.645. So that is the comparison. And since it is greater than that, means it falls into the rejection region. And what does it mean? Means the decision here is I am going to reject H now. All right, so that is how we carry out the test based on the value calculated, compare with the significant level, which give you the z-score 1.645, and then the decision here is H now is rejected. Okay, then you have to make your conclusion in the context of the questions here. So that means there is sufficient evidence at 5% significant level that we refer back to the questions. What does it want us to test? We want to test whether the mean yield has increased. So yes, based on our calculation, we reject the H now, right? And I explained just now, when we rejected the H now, H1 will be automatically accepted, which means the population mean should be greater than 8.2. So there is sufficient evidence based on our 5% significant level that the mean yield has increased. Okay, so this is the conclusion in context. And that is how we carry out the hypothesis test. Okay, the full working looks like this. All right. So that's all for this lesson. Please subscribe to the channel and like the video here. I see you in the next one. Bye-bye.
That's all for today's video. If you're interested in more genuine sharing by other geniuses, please subscribe to our channel and don't forget to turn on the notification bell, ding dong. Also, if you're struggling with one or two past year questions and the mark scheme just doesn't seem to help, Genie has got you covered. Feel free to let us know what question it is by filling in the Google form linked in the description below. GenieUs Hub will get genius teachers to fulfill your request for the solution. Genie will see you next time. Bye-bye.